All right, let's begin the next unit. We're now going to get into polynomial equations. And before we do that, well, actually part of doing that is learning about factoring, because that's going to be a huge part of the unit. And we're going to spend a lot of time on factoring because it's important to understand polynomial equations and what they represent, and we need to know how to factor to do that. So I'll begin with these basic questions. We're going to find the greatest common factor of a list of monomials, so we have a good idea of what greatest common factor means, and then we will factor out the greatest common factor from each polynomial. So we focus on that first question here about factoring out the greatest common factor. So what is the greatest common factor of this list of monomials? And so if we're going to do that, we should probably know some vocabulary. So if you don't know me by now, get used to known vocabulary, and also get used to vocabulary in kind of a unique way. So we're going to have to figure out what the greatest common factor is from a list of monomials. So let's first know, well, what in the world is a factor? So we got to figure, well, what is a factor? Factors are stuff you multiply. And that's my definition of a factor. It's stuff you multiply. So if you look at a number like 24, we can figure out, well, what are all the factors of 24? Basically, what are all the possible numbers you can multiply to get to 24? And the list of factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. How is that possible? Well, 1 times 24 is 24, right? And 2 times 12 is 24, and 3 times 8, and 4 times 6. Those are all factors of 24. So when we start talking about GCF, and we talk about the word factor, just remember a factor is stuff that you multiply. Now, in my years of teaching experience, what I have found is that the hardest part of GCF for students to understand is the C. What does common mean? Right? So we have to figure out, well, what does common mean? Common means they all got it. Okay, so that's my definition of common, that they all got it. And so a common factor is a factor that all the things have. So that's what common is. So for example, we go back to 24 and 16. The greatest common factor of 24 and 16 is the biggest, right? The biggest factor, stuff you multiply, that they both got. Okay, so what is the biggest factor that both 24 and 16 have? And so we figure out, well, the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. The factors of 16, 1, 2, 4, 8, and 16. So the greatest factor that they have in common, right, the greatest factor they all got is 8. So the GCF of 24 and 16 is 8. But then we start throwing wrinkles in the whole thing. We start bringing up variables. Well, how do factors of variables work? Okay, so take, for example, x to the 7th power. And what would be the factors of x to the 7th power? Well, basically, what is the stuff we multiply, right? Remember the definition of factor. What is the stuff we multiply to get to x to the 7th power? Well, we're multiplying x by itself 7 times. So, 1, 2, 3, 4, 5, 6, 7 x's. Those are the factors of x to the 7th power. So, take, for example, the greatest common factor of x to the 3rd, y to the 5th, and x to the 2nd, y to the 4th. And remember, a factor is stuff you multiply. Common means they all got it. So we have to look at each variable, each term, x to the 3rd, y to the 5th, what are all the factors of that? And x squared, y to the 4th, what are all the factors of that? And so we figure, okay, so x to the 3rd, y to the 5th, x times itself 3 times, y times itself 5 times, x squared, y to the 4th, x times itself 2 times, y times itself 4 times. And we got to figure out, okay, so what's the greatest factor or factors, the greatest number of factors that they both got, right? So what does common mean? Common means they both got it. They both got 2 x's and they both got 4 y's. And that is the biggest thing that they both got. X to the 2nd doesn't have a third x, and that's as big as they got. So the greatest common factor of those two terms, x squared, y to the 4th. So that leads us into into factoring. So with that vocabulary, we are ready then to begin addressing these this question here. So if you look at number 1, we have a term 4xy squared. And so we figure, okay, well, what are all the factors of 4xy squared? So the factors of 4 are 1, 2, 4. There's an x and there's a y squared. So that's the factors of 4xy squared. Now we're going to look at 16xy to the third power. And we figure, okay, so what are the factors of 16? There's 1, 2, 4, 8, and 16. There's an x and a y to the third power. Right? Then we look at 8x squared y squared. You know, what are all the factors of 8, of course, are 1, 2 goes into 8, 4 goes into 8, 2 times 4 is 8, and then 1 times 8 is 8. So 1, 2, 4, and 8. There's x squared, and then there's y squared. And then lastly, 20x squared y. So the factors of 20, you know, the gazintas, right? So 1 goes into 20, 2 goes into 20, 3 doesn't, 4 does, right? 4 times 5 is 20, so then 2 times 10 is 20, and 1 times 20 is 20. So we have our factors of 20. There's x squared, and then there's y. Okay, so we have all of our factors, the stuff we multiply to get to those terms, and now we've got to figure out what is the biggest factor that they all got, right? The common. What do they all got in common? And the biggest number they all got in common for the number part is 4, right? They all got a 4. That's the biggest number they got, so we know we're dealing with 4. They have 1x, by the way, I wrote a y. Sorry about that. They have 1x in common. They don't have any more than 1x in common because this doesn't have, these two don't have 2 x's, right? So this has 2 x's. This only has 1. So they don't all got 2 x's, but they all got 1, right? So 1, 1, 1, 1. So 4 x's in common. And you might think, well, looking at the y's, they all got 2 y's, but they don't. This one doesn't have 2 y's. It only has 1. So they all got 1 y. That's the biggest thing they got in common. So the greatest common factor, the GCF, is 4xy. And that is what a greatest common factor is. Okay? So now for the second set of instructions. Okay, now what we're going to do is factor out the greatest common factor from each polynomial. Okay, so now we got to figure, well, what is factoring? Right? Factoring is representing a number by showing its factors. Okay, so if we're going to factor a number, we're going to show it as a multiplication. Okay, so factoring is showing as a multiplication, which means it's kind of a subset. It's related to division. So factoring is actually related to division. Right? And that's kind of neat, right? So when we're going to factor, we're actually going to be dividing something. So for example, let's take that 24. I can show 24 as a multiplication of factors in a couple different ways. I can show 24 as 1 times 24. I can show 24 as a factor of 2, right? 2 times 12. Right? I can show it that way. Where do I get the 12 from? Well, because 24 divided by 2 equals 12, so I can rewrite it as 2 times something. I know 3 goes into 24, right? So I can show 24 divided by 3 is equal to 8. So 24 is 3 times 8. This is factoring. Okay, so what I'm doing is dividing each thing. The same thing with 4, right? So 4, well, 24 divided by 4 is 6. So I can show it that way, etc., etc. So factoring is related to division because I can show a number as a product, or I can show a term as a product. So factoring is related to division, and we use it to represent a product. And if you don't remember what product means, it's multiplication. So factoring leads us to represent a product. Okay, so the end in mind is to show something as a product. We're working backwards from multiplication. That's why it's related to division. If you remember in the previous unit, we were multiplying. Well, now we're going to be factoring because we want to represent a product. Which leads us to these three questions. So how do we factor out a greatest common factor from each polynomial? Well, if we look at number 2, what we're going to somehow do is represent this expression as a product of something. Right? So how can we show this one term as a product? Well, first things first, let's find out what is the greatest common factor. So if the first thing is we need to find out the GCF of those two terms. We have a 4y squared, and we have a 16xy to the third. We're going to have to figure out pretty darn quick, too. The faster you can be at finding the greatest common factor, the easier your life is going to be with factoring. So we know we have a 1, a 4, and a 2. So I'll put the 2 there as well. And y times y. For 16, we know 16 by now. 1, 2, 4, 8, and 16. And an x, and 3y. So the GCF is actually going to be 4y squared. Okay, so that's the GCF. They both have a 4, and they both have 2 y's, right? So 4y squared is the greatest common factor. So again, we know that the greatest common factor of these two terms is 4y squared. Okay, so we know that's the greatest common factor. So how do we factor out a GCF? We have to represent this term as a product. So that means once we identify the greatest common factor, we're going to represent that as a product of something. Okay, so we're going to be multiplying 4y squared times something to represent this. Okay, it all serves a purpose we'll learn later on in the unit. But for now, it's just getting comfortable. We're going to represent this as a product. So how do we find that product? Well, just the same way we did on the previous example. We're going to divide, right? It's related to division, so we're going to divide. If you remember, with those 24s, how do we show products of 24? We're going to be dividing 24 by those numbers, and so it's related to division. We're going to do just that. So we're going to have our initial expression, but divided by our GCF. Our initial expression divided by our GCF. The same exact way we did this, right? 2 times 12, well, where did 12 come from? 24 divided by 2. 3 times 8, where did 8 come from? 24 divided by 3. Okay, so it's going to be 4y squared times a thing. Where's that thing come from? Well, this initial expression divided by our GCF, right? All we have to do now is simplify, right? Laws of exponents and all that other stuff that we had learned. So all our previous material comes into play. So we have our 4y squared times a thing. Well, what's going to be left over? So if we look at our first piece, 4y squared over 4y squared is actually 1, right? It cancels out. Anything divided by itself is 1. So we know it's going to be 1. And then we have our minus 16xy cubed over 4y squared. So we're going to be simplifying the same way we did in previous units. 16 divided by 4 happens to be 4. And then y to the third power over y squared will leave us with just a y. And so we have a minus, a 4, an x, and a y. And we have to be careful of what we have left. And so we'll be left with minus 4xy. And we have now factored out the greatest common factor. And how do we know? There's no more common factors in this term. So there's no more common factors left in the inside the parentheses, as they say. And we have now represented it as a product. So we have factored out the GCF. And we are done. Okay? And that's how factoring works. So let's get some practice done, right? So we can look at the next one. And maybe we can go a little bit quicker this time. So if we look at number 3, we have 6x to the 5th minus 8x to the 4th minus 2x cubed. Right? So we're going to figure out the greatest common factor of those three terms. The biggest thing we multiply that they all got. Have you figured it out yet? I hope you have. They all have a 2, and they all have x to the third power. So the GCF is actually x to the third power. That is the greatest common factor. And so if we're going to factor out that greatest common factor, we're going to express the whole thing as a product, which means we're going to be multiplying 2x to the third power by something. And what are we going to be multiplying by? The initial term divided by the GCF. Again, remember what we did with that 24, right? How we represent 24 as a product of 4? We divide 24 by 4. All right, we're left with 6. So we're going to do the same exact thing, okay? So we have to divide the initial expression by the GCF. And so the initial expression, 6x to the 5th minus 8x to the 4th minus 2x cubed, each one of those is going to be divided by the greatest common factor. That's what division looks like, right? So all we have to do now is simplify all that garbage, and you'll start to be able to do this in your head, trust me. We simplify all that garbage in there, and then we'll be all taken care of. So we have our greatest common factor. We're expressing a product, and again, previous material. When we divide here, okay, 6 divided by 2 is 3. 3 of these cancel, leaving x squared. So we'll be left with 3x squared here. And now we have 8 divided by 2 is 4, and x to the 4th divided by x to the 3rd cancels out, leaving me 1x, so that's minus 4x. Careful with signs, right? And then lastly, minus 1, because this all cancels, leaving us with a big, big 1. So it's going to be minus 1. And that is our expression. And we know we're done because there's no more common factors inside the parentheses. So no more common factors, so we're finished. We have expressed the initial expression as a product. Okay, so we have expressed that as a product, and we are done. So let's see if we can do some stuff in our head now with a more complicated expression. So now we have a bigger one, right? So a bigger one. First things first, we're going to identify the greatest common factor of all of these. All right, we look at 12 and 6 and 18. What is the greatest number that they all have in common? And hopefully by now you have seen that it is 3. And now we look, they all have at least an A, but the biggest A they have in common is only that 1, so 3A. And now they all have B's, but the biggest thing they have in common is 1B. So the greatest common factor is 3AB. So we know we're going to be expressing this as a product of 3AB. So how can we do this in our head? Well, I'm going to do a think aloud, and hopefully you can follow along. So we have 12 a to the third b divided by 3ab. 12 divided by 3 is 4. A to the third over a, one of those a's is going to cancel, leaving us with a squared, and our b's are totally gone. So we're left with that. And now we have our second term. 6 divided by 3 is 2. The a's cancel and the b's cancel, so we're done with that. Moving on to the third. So now we have 18 divided by 3 is 6. So we have a plus 6. And I completely ruined that entire video. No, I'll keep going. Check this out. So we have 6. 18 divided by 3 is 6, and then we have our a's cancel, and so we're left with b, right? And now we have 18 divided by 3 is also 6. One of our a's cancel, and our b's are totally gone. And so we have this. And now we know we're done because we have no more common... Whoa, wait a minute. There's a common factor left. So when I had my GCF as 3, hopefully you caught that I made that huge mistake. Big mistake. I'm running with it because it's the last one. I'm not going to re-tape a whole video. So I'll run with it. Clearly that was not right because look, we have a 2 in common. All of these still have a 2. I'm not done yet. I'm not done yet. I could factor out another 2. There's a 2 in common. There was actually 6 in common the whole time. So what does that mean? That means I can factor out a whole nother 2. I can divide all of these by 2 and then multiply the original by 2. and then I can actually be done. So that's what's happening, right? I can totally check myself before I actually wreck myself. So I'll have a 6ab and then a 2a squared minus 1 plus 3b minus 3. So I made a mistake, but it was a good learning experience, I hope, and don't mind the flub because I am certainly not going to re-record an entire video because of that mistake. So I'm left with that. Whew! But at least we know we're not done, and that's how we can work with that. And you can even check yourself before you wreck yourself like I almost did. So anyway, that's factoring, greatest common factor. And even if you screw up, you can still fix it, as I have almost again, as I have done. So there you have it. And that is it for factoring so far.